Hello, and welcome to this video on Introduction to Data Structures. My name is Haider, and I'll be your guide throughout this video. Data structures are fundamental building blocks in computer science. They allow us to organize and manage data efficiently, which is crucial for developing effective software applications. In this video, we'll explore 6 critical data structures: arrays, linked lists, stacks, queues, trees, and graphs. So let's get started and embark on this journey to mastering data structures. Let's start with arrays. An array is a collection of elements of the same data type stored in contiguous memory locations. This direct access capability makes arrays extremely efficient for read operations. Arrays are great for storing and manipulating large amounts of data. However, arrays come with a fixed size, meaning you need to define their length when you create them. Despite these limitations, arrays are one of the most fundamental data structures and serve as the basis for more complex structures like lists and matrices. In summary, arrays provide a straightforward and efficient way to store and manipulate collections of data. Next, let's explore linked lists. A linked list is a dynamic collection of elements, where each element, known as a node, points to the next element in the sequence. Unlike arrays, linked lists do not store elements in contiguous memory locations. This allows linked lists to be more flexible in terms of memory allocation. Linked lists are particularly useful for scenarios where you need to insert or delete elements frequently. One of the key advantages of linked lists is their ability to grow and shrink dynamically. However, this flexibility comes at the cost of slower access times. There are different types of linked lists, such as singly linked lists, doubly linked lists, and circular linked lists. Despite their advantages, linked lists also have some drawbacks. In summary, linked lists offer a flexible and dynamic way to manage collections of data. Moving on, let's discuss stacks. A stack is a last-in, first-out (LIFO) data structure where elements are added and removed from the top of the stack. This LIFO behavior makes stacks particularly useful for scenarios where the most recently added element needs to be accessed first. Stacks are commonly used in various applications, such as parsing expressions, managing function calls, and implementing undo mechanisms in software. One of the key operations in a stack is the push operation, which adds an element to the top of the stack. The opposite operation is the pop, which removes the element from the top. Despite their simplicity, stacks are powerful data structures with a wide range of applications. Understanding how to use stacks effectively can significantly enhance your problem-solving skills in programming. Next, let's delve into queues. A queue is a first-in, first-out, or FIFO data structure, where elements are added to the end of the queue and removed from the front. This FIFO behavior makes queues ideal for scenarios where the order of processing is crucial. Queues are commonly used in various applications, such as job scheduling, print queues, and managing tasks in a multi-threaded environment. The primary operations in a queue are the unqueue operation, which adds an element to the end of the queue, and the dequeue operation, which removes the element from the front. Queues can be implemented using arrays, linked lists, or circular buffers. Despite their straightforward nature, queues are powerful data structures with a wide range of applications. Understanding how to use queues effectively can significantly enhance your ability to design efficient and fair algorithms. Now, let's explore trees. A tree is a hierarchical data structure consisting of nodes, where each node has a value and 0 or more child nodes. Trees are particularly useful for representing hierarchical relationships and organizing data in a structured manner. One of the most common types of trees is the binary tree, where each node has at most 2 children, referred to as the left and right children. Trees are widely used in various applications, such as representing organizational structures, file systems, and decision trees. One of the key operations in a tree is traversal, which involves visiting all the nodes in a specific order. Despite their advantages, trees also have some drawbacks. In summary, trees provide a versatile and efficient way to represent hierarchical relationships and organize data. Finally, let's discuss graphs. A graph is a non-linear data structure consisting of nodes, also known as vertices, and edges connecting them. Graphs are particularly useful for modeling complex relationships between data, such as social networks, transportation networks, and dependency graphs. One of the key characteristics of graphs is their ability to represent both direct and indirect relationships. Graphs can be classified into different types based on their properties. One of the key operations in a graph is traversal, which involves visiting all the nodes in a specific order. Graphs are widely used in various applications, such as finding the shortest path in a transportation network, detecting cycles in dependency graphs, and analyzing social networks. Despite their versatility, graphs also have some challenges. In summary, graphs provide a powerful and flexible way to model complex relationships between data. That's it for this video on Introduction to Data Structures. We've covered the basics of data structures, including what they are, why they're important, and the different types of data structures. Data structures are fundamental to computer science, and mastering them is essential for developing efficient and effective software applications. By understanding the characteristics and use cases of arrays, linked lists, stacks, queues, trees, and graphs, you are now equipped with the knowledge to choose the right data structure for different problems. Thanks for watching, and we'll see you in the next video. If you found this video helpful, don't forget to like, share, and subscribe to our channel for more tutorials and guides on coding and data structures. Happy coding, and see you next time!